Okay. Okay. I think we're good. Right. Thanks, Taylor. Right. I am Doug Sorrell from NC State University, and that's my main affiliation. So come here today through some work I've been doing with NOAA, National Centers for Environmental Information, as well as the newly established NOAA Center for AI. So I pretty much work for a federal data center in a place where it's not very much not decentralized. It's very much centralized place where we disseminate petabyte scale of data sets, one of the world's largest environmental data archive that we have. And for environmental applications, the claim to fame is that from the bottom of the ocean to the surface of the sun, so collecting data from the seafloor all the way up to the surface, solar dynamics, as well as the space weather. So I think the whole topic that I will be talking about is that really in the era of AI or machine learning or deep learning, whatever you want to call it, what's the role of this open geospatial data and the data providers can play in this time. And that may lead to, I really enjoy some of the conversation we had earlier on this related topics. So if you're not aware, we're in the era of AI, that this is a picture I took yesterday on Metro, not far away from where we are right now. Two of the events happening in in the next month on AI weeks, and then the transformative power of AI in the government that everyone is talking about. That if you look at proposals or papers, probably everyone is going to mention AI or machine learning at some points in that case. Oops. And I want to ground my conversation from the broad artificial intelligence. Like I'm using Galaxy here as an example. We're not talking about much broad AI or artificial intelligence. In general, it's more like traditional terms of machine learning in this case, and how geospatial data can be and will be used in those contexts. More specifically in this workshop, really is the machine learning with geospatial data, and intentionally include this like night lights data from NASA, specifically thinking about geospatial data. It's not just about the environment, physical environment, also the human systems in the Earth systems that we are pretty much involved daily, like the geolocated Twitters and the informations. So one of the efforts that through NOAA Center for AI and another organization I'm going to mention later on is called AI Ready Data. So this is the motivation code that I often use from Intel. Really, you are not AI ready until your data is. Oftentimes, when you're trying to build developments or develop AI applications, that data is the foundation. What you're trying to do with those data and sourcing, organizing, and feeding the right data, right kind of data into the model or the application development processes. But like the fundamental question we have always been asked for the past 2 years when I started working on it, what is really AI-ready data? And that's still, the jury is still out on that, what's the definition is, but I use the national AI strategy from UK, where they call it data foundations, are the data that fit for purpose and recorded in standardized formats on more than future-proof systems and fair. So fair is a term that have been used multiple times in this workshop as findable, accessible, interoperable, and reusable. And there are 3 dimensions to those when we're defining what really is fit for purpose, right? There's what specific use case you're talking about, what data types are we talking about, whether it's imagery or time series or different type of the data, and then what's the modeling techniques in the context of AI R&D processes. So it's still a puzzle that we are trying to piece together. This is a quote that's funny and also intriguing at the same time from the creator of Keras. It's like preparing the data, although it's really important and almost like cannot be ignored in when you're developing AI models, but preparing the data is an exercise left to the readers. We are not even touching the messy subject in this context. And as a data center, that data has been constantly used by ML developers. We are trying to figure out what can we do to improve the data management, stewardship, and services to make that possible and also responsible for those developments. And the organization that I am mentioning right now is called Earth Science Information Partners, or short for ESIP. It's a community. It's also a nonprofit organization. I know Rachel and some others in this group might be have heard this terms before. It's really bringing together the federal agencies, universities, as well as the research community together, working specifically on the earth science data. And this year, the theme is grounded in trust, like data to enable the collaborations across the community. And within there, we have a community-driven efforts called AI-Ready Data Initiative. And when we're talking about AI-Ready data, we define it in 4 aspects: the documentation, quality information, access, as well as preparation, where the documentation is really to increase the data usability. The quality information is to determine the fit for purpose of specific developments cases, and the access are really can enable the efficient and effective and reproducible manner for the AI research and development process. And the preparation is to identify the common patterns, how those data are used, and what can be used to enable data service and tools from a data center or repository point of view. And the group has been bringing people from NOAA, NASA, Geological Survey, Department of Energy, Air Force, and recently Met Office and the World Data Systems from other countries as well. And going a little bit more details about each individual characteristics, like quality, a lot of times bias has been mentioned multiple times by many stakeholders. Completeness, consistency, and provenance. I think that there's some conversation today about provenance is intriguing and how those might be useful for when we're talking about individual data sets or the multiple data sets in terms of provenances. And documentation, really the common metadata standards are the key in that, but the other ones that the request from the users about how the tools and examples can be provided to enable the use of the data, like the computational notebooks have been mentioned, that becomes more digital artifacts being used more and more in these ecosystems. The identifiers and the license information, how those data can be used. Access is another piece where the security, privacy, and users' right has been emphasized by people, especially in the age of generative AI. And all the agencies are now trying to grappling with how those data might be used or should be used in the generative AI context. And for the preparation piece, really different type of the processing has been requested and emphasized by different users. Really, all the things has been included in our GitHub repository on the bottom of the page, on the bottom of the slides, that if you're interested, take a look. And we are using that as a way to directly share the information that we've been working on recently. So where are we going from there? I think there are a lot of conversation about principles, open science principle, data principles. Those are great things to have. But when we get into implementation principles, it becomes not enough, right? Everyone has their own implementation or interpretation of what principles might mean to their case. Just talking about FAIR, it has been there for almost 10 years. Everyone still have a slightly different definition of what FAIR might mean in their ecosystem or in their context. And now there's FAIR for software, FAIR for workflows, FAIR for virtual environments, or virtual libraries, and etc. And then frameworks becomes the collection of different principles that being stitched together to enable certain workflows or certain activities that under it. And then there's always the convention, guidelines, specifications that have been developed, like the CF convention, climate forecast convention, has been often used in many of the satellites and geospatial data components that gets a little more tangible, that you have really specific details about what we're looking at in those case. And then the standards becomes much more defined and specific, and there often has those verification and certification process that becomes the implementation and requires the resources and the infrastructure to do that. So recently, through the ML Commons and a lot of industry participation from Google data set search, there's something we have been working on called Croissant. It's based on schema.org, trying to create a high-level metadata formats to enable that search creates a load and download of those machine learning data sets that it's already implemented in Kaggle, Hugging Face, OpenML, as well as the Google dataset search. That makes it streamlined for how you can find the specific machine learning based data sets and how those can be directly integrated into the PyTorch and other the data science frameworks to load data without trying to go through the whole processing steps by yourself. You can find more on ML Commons website that we have been working on, and we are already talking about next iterations. And so I'm gonna end my presentation with this last quote, try to mimicking what Kara's creator says, really in the context of decentralized web and federated data ecosystems, that a lot of things we have been working on really focus on individual or selected sets of data or subsets of the data. And what might be the solutions? How can we enable those application developments with geospatial data? It's really an extensive community effort that we don't have the answer for and need more. I would like to hear more questions or like solutions you might have to help us on this moving towards that direction.
One thing that I think is really interesting in how data is being used specifically for ML models is that we're seeing companies like Google pay companies like Reddit orders of 9 figures per year in exchange for their data. And this is data that cannot normally be obtained by a regular end user. You can't go through and scrape all of Reddit yourself on one machine or even multiple machines that you own, because they're going to find out and they're going to know, or even if you run a data center, you can't do it. So what a proposed solution that I've seen is the sort of browser extension that you install that then utilizes your excess bandwidth to scrape on multiple websites and accumulate data for people to use. One thing that I think is interesting about this is that it's sort of the whole reason why it works is that these are everybody's users, everybody's computer. It comes in as a normal IP address, and it's sort of like a next step in this sort of arms race between AI, because every company like Google that can afford to pay this exorbitant amounts of money for this data is going to have better models than people working in an open framework. So I think improving on this technology and iterating on this technology can sort of level the playing field, because I think that these models are too powerful to be left in control of these large corporations.
I totally agree that the consolidation of the players in developing those like big models in terms of the more like the data provided by federal data centers, those are all publicly available, right? That anyone can use it. I think it's really the fine tuning of those like other scale, other processing of done with those data and how those can be shared and then reduce the burden and the redundancy for the larger groups and the other people who want to use it. I think there's a hand. You are 100% right. Using semantic web can be a huge pain. There are a lot of harmonization efforts going on within the geospatial community that within ESEP, there's a specific group called semantic harmonization, right? Trying to figure out how you harmonize different semantics within different scientific disciplines. And also if you're trying to look at, with the United Nations, there's the the ocean decades, right? That like all those countries trying to contribute to better understanding the ocean, and everyone's collecting different data, and the semantics ontologies and under the hood are really need to be worked out. So that's an international effort trying to harmonize that, and also ESEP is playing a role in that. And one specific thing with schema for scientific data, there's something called SOSO, which is a science on schema.org, really trying to make the scientific data more integrated into schema.org system, where those can be used through the Google or the data commons that kind of like started by Google, but now finds life. I know the census is also trying to modernize their data by be compliant with the schema.org, which if you use the old sensors like data search, which can be a huge pain, and now it's much easier to use with when they spend quite a lot of efforts to make it more schema or compliant.